Hello, and welcome to Liam Carden's term project for CMU 15112 Fall 22. So this is what happens. This is the window that displays when you run the main Python file. And this is a circuit simulator called Circuit Lab that can handle resistors, capacitors in basic series and parallel. And down here we have our documentation as to how to use the app. And the overall main component is that we have these commands and this command line where we can input them. So we're going to start off. I have some pre-built commands. So these resistors just been placed. They have 3 ohms each. So we can run the analysis. And I'm just going to make this full screen. As you can see, the yellow implies that current would be running through them. And so we can go ahead and display the circuit. Obviously, 9 volts, 9 total ohms, 1 amp of current by Ohm's law. So let's go ahead and reset here. And let's type in another command to get another pre-built. And this is designed to showcase overall the complexity of the simulation. So if we go ahead and just look at this real quick, up here we have 3 paths that are all in parallel, 2 of which are going to contain a capacitor, so from 4 to 9 to 10, 5 to 8 to 10, and then one of which is just resistors 3 to 6 to 7 to 10. If we go ahead and run this, as we can see, only the paths that contain capacitors have current running through them. Well, the reason for this is because if we go ahead and we display the time, then we can see that the time is 0 tau, which means the capacitors are just beginning to charge, and so they are taking the full amount of current. Now, if we go ahead and we say swap time, and then we just demonstrate display time, it's now at 5 tau, which means that the capacitors would be finished charging. If we rerun our analysis, we see that while the rest of the circuit remains the same because it's just resistors, we have the capacitors are they've been fully charged. So if we go ahead and we display four, it has a voltage drop of 9, so it's been fully charged, but it has no current because no current is running through to charge it anymore. And that means that all the current is running through these resistors. If we go ahead and we display the circuit, we can clearly see what the voltage, the current, and the resistance would be. If we go ahead and store this value up here real quick, and then let's just swap time, run, and then let's just display circuit. And as you can see, because we aren't running current through these resistors and we are only running current through these, our total resistance changes, which means that our current would change, and therefore the analysis over each of these components, including 12, 13, 14, 1, and 2, would change as well. So that is the gist of my project. There is more to be discovered, including drawing, more stuff with display, but that is the brief overview. Thank you very much.